Today's lesson is 9.6, long division. Example 1 wants us to divide this binomial times this monomial. And it wants us to simplify our answer as much as possible. What I'm basically going to do is I'm going to take the second polynomial, the monomial, and I'm going to divide it by each one of the two terms in the binomial. So I'm going to start with 10x squared v to the fourth, and I'm going to divide that by negative 2x to the third v to the fifth. Then I'm going to take the second part of my binomial, and I'm going to think of it as negative 13x to the third v to the fifth. There we go. And I'm going to divide it by negative 2x to the third v to the fifth. Now what I'm going to do is I can simply use my laws of exponents. I'm specifically going to use the quotient rule, which says when I have the same base in the numerator and the denominator, I can go and subtract the exponent's numerator minus denominator. I'm also going to use this idea that if I have a power outside, it is going to go to both the numerator and the denominator. I will be seeing this one right here, which says if I have a negative exponent, it is going to send that base to the bottom where the exponent will be turned to positive. And then we're either going to see, I can't remember if it's this one or this one. We're going to see one of these two. All right, let's go ahead and get started. Okay, so the first thing I'm going to do is I'm going to pair up my two coefficients. And so what I'm thinking is, what is 10 divided by negative 2? After that, I'm going to pair up my x's. And I'm going to follow the rule over here. The rule says that when I have the same base in the numerator and denominator, I can subtract the exponents, numerator minus denominator. And I can do that for the v's as well. Numerator minus denominator. All right, let's move on to the second one. I'm going to once again pair up the coefficients. And I'm going to see if I can divide negative 13 by negative 2. If I cannot divide them, then I'm going to go ahead and I'm going to leave them as a fraction. All right, same thing here, numerator minus denominator. And same thing for the v, numerator minus denominator. All right, let's actually go in and start dividing and subtracting. So for the first one, 10 divided by negative 2 would give me negative 5. And x to the 2 minus 3 would give me negative 1. V, 4 minus 5 would give me negative 1 as well. So for this first term, I'm noticing that I have this right here. I've taken care of the quotients here, and now I have these negative exponents. What's going to happen is that these two bases, x and v, are going to get sent to the denominator, and my numerator is going to be 1. The 1 to the n would stay 1, and I would multiply it by the negative 5 that's there. So the negative 5 is the only one that's staying in the numerator, and the x and the v are going to go to the denominator, and they are going to become positive. So my first term looks like this, negative 5 over x v. Because take a look right here, if I raise it to the first power, it's just the base. I don't have to put the first power. All right, let's look right here. Negative 13 divided by negative 2 is going to turn into positive 13 divided by 2. It's not going to, it would change into a decimal, but you don't want to use that. 3 minus 3 is 0, and 5 minus 5 is also 0. If I go ahead and take a look at my table, whenever I have any base raised to the 0 power, my answer becomes 1. So take a look at what's happening right here per the 0 exponent law. I have 13 over 2 times 1 times 1. Well, anything times 1 is that thing. So that thing would be my fraction, 13 over 2. It is positive, so I'd put a plus in between. I cannot add these two fractions together because there's no x or v with the second, with the 13 over 2. That would be my final answer. All right, let's move on to example number 2, where they are asking us to divide a trinomial, a quadratic, by a binomial, a linear. This is the one where I would grab my old school division, and I'm going to take my quadratic, the first one, the trinomial, and put it underneath, just like you would in a division problem. And then I'm going to take my binomial, the linear, the second parentheses, and I'm going to place it outside. All right, now I'm going to work with my leading terms. So my leading term outside would be the x, and my leading term inside would be the 4x squared. What I'm going to be doing and thinking off to the side, let me grab a different color so that you know I'm thinking off to the side. I'm going to take the 4x squared and I'm going to divide it by the x. So I always take the blue one inside and divide it by the purple one outside. I never use the 2 and I never use the 12x plus 7. I'm not going to use those, not yet. All right, so 4 is divided by nothing. And then remember the rule says it's x squared minus it's the square on the top minus the 1x on the bottom, so it would give me just x. You could also think of it as 4x times x over x, and then these two would cancel out, giving you your 4x. You could think of it that way as well. I'm going to take this answer that I got and I'm going to put it on the top. Sometimes we offset it, sometimes we don't. It doesn't really matter. And now what I'm going to do is I'm going to distribute the answer I got back to the divisor outside. So I'm going to be thinking in my head, what is 4x times x plus 2? So I'm going to be going ahead and distributing that. I should get back that 4x squared that is underlined in blue. If they do not match, then you did something wrong when you divided. And I get 8x, right? 4 times 2 is 8, and the x tags along. I'm going to go ahead and write this right here. Okay. I am going to go ahead and subtract. I'm going to go ahead and subtract both of them. So I subtract, let me grab this, and so that the first leading coefficient cancels out. And then I'm going to subtract as well here to get a new leading coefficient. If there's anything else to bring down, I'm going to go ahead and bring it down. And now this becomes my leading coefficient, and I'm going to start the thinking process all over again. So I'm going to think, what is 4x divided by that purple x? Here I can easily see that my x's will cancel, leaving me with 4, which I'm going to go ahead and put on the top. Because it is positive 4, I'm going to put a plus in between. If it had been negative 4, I would go ahead and put a negative. Once again, I'm going to distribute the 4 to the x plus 2 that is outside. I'm going to distribute this to this right here. So 4 times x is 4x, and 4 times 2 is 8. I'm going to go ahead and write that right here. And as you can see, once again, my leading term matched my second blue leading term right here. They match once again. I'm going to go ahead, and subtract. I need to subtract so that the leading terms will cancel out. And then I just need to remind myself that I am subtracting. And 7 minus 8 is negative 1. On your assignment, you will be asked, what is the quotient? And then you will be asked, what is the remainder? Well, it's very simple. The quotient, let me grab a color. The quotient is right here. So you would put in 4x plus 4 into the box, and the remainder is right here, and you will simply put -1. Let's try one more, and then we'll be done. All right, so divide, and now we have a polynomial because it has 4 terms divided by a binomial. Once again, I'm going to make my old school division box. I'm going to put the first one inside, which is the polynomial. Squared plus 16x plus 11. And I'm going to take the second polynomial, the binomial, and I'm going to put it out front. I'm going to go ahead and identify my leading terms. My leading term outside is 2x, and my leading term inside, the first leading term inside, is the 6x to the third. So just like in the last one, I'm going to take my 6x to the third, and I'm going to divide it by the 2x. So I always take the blue one and divide by the purple one. All right, so 6 divided by 2 is 3, and x to the third divided by x would be x squared. Think of it this way. There's 1, 2, 3 on the top. There's 1 on the bottom, so only one pair of the x's would cancel out, leaving you with 2. All right, we're going to put that answer up on the top, but give me just a minute because I also have to think what is 3x squared times 2x plus 2. I have to go ahead and distribute it. I should get back my leading coefficient. This one should match that one, and it does. So that just tells me that I divided correctly. 3x squared times 2 is 6x squared. All right, so on the top, I'm putting 3x squared. And here I'm going to put the 6x cubed plus 6x squared. And now I'm going to go ahead and I'm going to start subtracting. Okay, so I subtract so that these cancel. And then I have to remind myself, I like to bring it over as well because sometimes I forget I'm subtracting and I'll do 12 plus 6 and think it's 18, but it's 12 minus 6 and it's actually 6x squared. I'm only going to bring down the 16x. I have seen it where you bring down this as well and you think of it as this, but we really can't use the 11 until the next step. So I'm just going to go ahead and leave it. All right, so here we go. Here is our new leading coefficient, and now I have to think of dividing that one by the purple one outside. So once again, 6 divided by 2 is 3, and x squared divided by x would be x. I have x times x over x. Those two would cancel out. There we go. I also need to think of what is 3x times 2x plus 2, and I have to do the distributing. Does this have to be written down? No. If you can do this in your head, perfect. Notice this one and this one, they match. This one and this one, they match. So that lets me know that I multiplied correctly, that I divided correctly. And 3x times 2 would be 6x. All right, I'm ready. So on the top, I'm going to put the 3x. This one always goes up to the top. And then this one is going to go right here underneath. Since it is a positive 3x, I'm going to put a plus. And then this one is just going to get written how it is. There we go. We're going to go ahead and subtract. And we're going to go ahead and subtract. So these two will cancel. They always should cancel and leave you with with a new leading coefficient. And 16 minus 6 is 10x. And now I can finally bring down the 11. And one last time, let's do the 10. Okay, so let's think. What is 10x divided by 2x? Well, 10 divided by 2 is 5, and I can see right here that the x's would cancel. I'm going to multiply 5 times 2x plus 2. 5 times 2x is 10x. Notice that they do match. These last leading coefficients, they do match. And 5 times 2 is 10. All right, so I'm going to go ahead and put the 10x plus 10 right here. And I've got to bring the 5 up to the top. It is a positive 5, so it's going to get a plus. The last thing I have to do is I have to subtract. These two are going to cancel, and 11 minus 10 is 1. Once again, it's going to ask you for your quotient. And it's going to ask you for your remainder. All right, don't forget that your quotient is right up here. I'm going to write it down here like this so that it fits. And that your remainder is the number down here at the bottom. Yes, you could end up with a remainder of 0. If you end up with everything canceling, it can happen where these would cancel just like these would cancel, and you would then have 0 if that happens. But otherwise, you're going to have something like this.